Let's start from Boolean operators. So what we're going to discuss here is Boolean operators. So we've already seen here we might count, say, all days with rain less than 4 inches or all days with rain greater than 2 inches. But what if we want to know about all days with rain less than 4 inches and greater than 1 inch? This is accomplished through Python's bitwise logic operators, which are some of them are this. Like with the standard arithmetic operators, Numpy overloads these as ufuncs that work element-wise on usually Boolean arrays. Let's start with an example. For example, we can address this sort of compound question like this: np.sum inches greater than 0.5 and inches, then must give the answer 29. It must give the answer 29. I don't know why it's not. Yeah, it gives answer. So we see that there are 29 days with rainfall between 0.1 and 1.0 inches. Note that here the parentheses are important because of operator precedence rules. With parentheses removed, this expression would be evaluated as follows, which results in error. Like, for example, this will result in error. Using the equivalence of A and B and not A or B, like this, which you may remember if you have taken an introductory logic course. We can compute the same result in a different manner. np.sum minus now we will write let's put another bracket. Now let's put inches equals to 1. This may result in 29 as well. I guess we made an error here. No, that results should be in 29. Let me see that what we made an error here. We must make a minus sign. Honestly, I don't think so. Why we are making an error here? The numpy boolean negative, the negative is not supported. Use the oh, that was a huge mistake. We should use this. Now that results in 29. So combining comparison operators and Boolean operators on arrays can lead to a wide range of efficient logical operations. Okay, so now let me show you a table here, which table that summarizes bitwise Boolean operators and their equivalent. So using these tools, we might start to answer the types of questions we have about our weather data. Here are some examples of results we can compute when combining masking with aggregations. Let's start with the print. We want to print number days without rain. One, two, three, four, five. And p dot sum inches. Sorry. Gonna copy that down. Print days with more than 0.5 inches. Print rainy days with less than 0.1 inches. Or we can write less than. So we got an answer. The first one is number of days without rain is 215. Number days with rain 150. Days with more than 0.5 inches 37, and rainy days with less than 0.1 inches is equal to 75.